Dear students, in today's lecture, we will see the parametric form of circle. Then what is mean by tangent, equation of tangent to the standard circle. Then equation of tangent in parametric form, condition of tangency, tangents from a point to the circle. And also we will see directed circle of standard circle. Okay. Let's see one by one. First we will see parametric form of circle. For that, you consider a standard circle here. That is a circle whose center is at origin. Let Pxy be any point on this circle. Here O is center. Then join OP. And what is this OP? This OP is nothing but radius of the circle. Now you draw perpendicular from point P on x-axis. Suppose this is perpendicular PM on x-axis. Then we know that if point P has coordinates x and y, then this distance OM is nothing but x and this distance PM is nothing but y. Okay. Now we will consider that this OP makes angle theta with positive direction of x-axis. Means major angle XOP is theta. Okay. Now we will write down all this. Let Pxy be any point on the circle. Let O be the center and radius R. Okay. Let OP makes angle theta with positive direction of x-axis. Okay. Therefore, this major angle XOP is theta. Okay. Here center is origin, radius is R. Okay. Now here draw PM perpendicular to x-axis as shown in the diagram. If we draw PM perpendicular to x-axis, then this OM is nothing but x coordinate of point P and PM is nothing but y coordinate of point P. Okay. Now this triangle OPM is right angle triangle. This OPM is a right angle triangle because this angle PMO is 90 degree. Okay. Now as we have seen in the chapter trigonometry how to find cos theta and sin theta, we will find here cos theta. What is mean by cos theta? Cos theta means adjacent side divided by hypotenuse. Here adjacent side is OM, hypotenuse is OP. OM is nothing but x coordinate of point P and OP is R. Similarly, we will find out sin theta. Sin theta means opposite side divided by hypotenuse. Opposite side PM is Y, hypotenuse is R. Okay. Now from this equation cos theta is equal to x by R. Value of x will be R cos theta. And from this second equation sin theta is equal to y by R, we will get y is equal to R times sin theta. Okay. Now in this way we have got value of x r cos theta and value of y r sin theta. This is nothing but parametric equation of circle. This is parametric equation of circle. Which circle is this? This is the standard circle. Therefore, this is parametric equation of circle. X square plus y square is equal to r square. Okay. Where theta is called parameter. Now this point P has coordinate xy. Okay. Then what is the value of x here? X is r cos theta and y is r sin theta. Means these are coordinates of point P in parametric form. Okay. And this is parametric equation of circle. Similarly, we can find out parametric form of general circle. We have derived the equation of general circle simplifying the equation of circle which is in center radius form. Therefore, instead of writing equation of circle in general form, we will write equation of circle in center radius form. Therefore, parametric form of circle x minus h square plus y minus k square is equal to r square is x is equal to h plus r cos theta and y is equal to k plus r sin theta. You remember this? This is parametric form to the general circle or circle in center radius form, and where coordinates of point P are xy means x coordinate is h r cos theta and y coordinate is k plus r sine theta. Okay. Standard equation of circle is what? Standard equation of circle is x square plus y square is equal to r square. Here center is what? 0, 0. And radius is r. Okay. Therefore, parametric form of equation of circle is x is equal to r cos theta, y is equal to r sine theta. Okay. Here, parametric form of x minus h square plus y minus k square is like this. And for this equation of circle in center radius form, what is center here? Center is hk. Therefore, you only add in this equation center h plus r cos theta, y is equal to k plus r sin theta. Means in this equation, if equation is in standard form, this is parametric equation of circle. But if it is in center radius form, you add the coordinates of center, that is h plus r cos theta, and here k plus r sin theta. Only the difference is that, and these values of x and y are nothing but coordinates of point p, x, y. Okay. Then we will see what is mean by tangent. Tangent is a line which touches the circle at only one point. Okay. When a line intersects a circle in coincident points, then that line is called tangent of circle. You simply remember that tangent is line which touches the circle in only one point. Okay. Now we will find equation of tangent to the standard circle, that is to the circle x square plus y square is equal to r square at point P, x1, y1 on it. Okay. Now draw the circle whose center is at origin. Let P, x1, y1 be any point on the circle. Draw tangent from this point to the circle. Now here you write down, consider the standard circle, x square plus y square is equal to r square. Okay. Let center at origin and radius of circle with the r. Okay. Here you write down, let p x1 y1 be any point on this circle. Now here we know the coordinates of center O, we know the coordinates of point P. Then if I join this OP is nothing but radius. We can find out slope of this OP. Then what will be slope? If we know any 2 points on a line, then we can able to find the slope of line using the formula that difference of y coordinate divided by difference of x coordinate, as we have seen in the chapter straight line. Okay. Then what will be slope here? Take the difference of y coordinate in the numerator, that is y1 minus 0. Difference of x coordinate, that is x1 minus 0. And after simplifying, we will get slope of OP y1 divided by x1. Now we know that one of the property of circle which we have studied in 10th standard, that tangent is always perpendicular to radius of circle. And this OP is nothing but radius. Means this tangent is perpendicular to radius. Okay. Therefore you write down, draw tangent at point P. Then by property of circle, OP is perpendicular to tangent at P. Okay. OP is radius and it is perpendicular to tangent. Okay. Then what will be slope of tangent? Here we know the slope of OP. OP is perpendicular to tangent. Therefore, slope of tangent, if I consider it as m, then what will be that? That will be minus time reciprocal of slope of OP. Because we know that if two lines are perpendicular to each other, product of their slopes is minus 1. Therefore, slope of tangent will be here minus time reciprocal of slope of OP. And that will be minus x1 divided by y1. Okay. Now here we know the point P, x1, y1 on the tangent. If this is tangent, we know the point P, x1, y1 on the tangent. We also know the slope of tangent, and we can able to find the equation of tangent using slope point form. Therefore, you write down here, equation of tangent in slope point form is y minus y1 is equal to m times x minus x1. Point is x1, y1. Now value of m, that is slope, is minus x1, y1. We will keep that in the next step. Now simplify this. Take this term to the left hand side. This will be y1 minus y1 square is equal to minus x1 minus minus plus x1 square. Okay. I will transfer this negative term to the left hand side and this negative term to the right hand side. Then I will get x1 plus y1 is equal to x1 square plus y1 square. Now suppose this as equation 1. Now we know that as this point P x1 y1 lies on this circle, this point P will satisfy the equation of circle. Therefore we will write that as point P x1 y1 lies on this circle, x square plus y square is equal to r square. It satisfies the equation of circle. Keep value of x1 and y1 in this equation. Then we will get x1 square plus y1 square is equal to r square. And suppose this as equation 2. Now keep equation 2 in 1. And what is our equation 1? Our equation 1 is x1 plus y1 is equal to x1 square plus y1 square. I will keep the value of x1 square plus y1 square r square in this equation. Therefore, this equation becomes x1 plus y1 is equal to r square. And what is this? This is nothing but equation of tangent to the standard circle. Therefore, this is equation of tangent to the standard circle x square plus y square is equal to r square at point P x1 y1. Okay, this is your equation of tangent to the standard circle. You remember this as a formula. In this way it is very easy to find the equation of tangent to the standard circle. Similarly, we can find out equation of tangent to the general circle. Let's see what is it. You write down. By the same way we can find out equation of tangent to the general circle. Now what is the equation of general circle? That is x square plus y square plus 2gx plus 2fy plus c is equal to 0. In the same way we can find out equation of tangent to the general circle at point P x1 y1, and that will be x1 plus y1 plus g into x plus x1 plus f into y plus y1 plus c is equal to 0. This is equation of tangent to the general circle. And see how this comes. Here you split this, you write down this x square as x into x, this y square as y into y. This 2gx means g, and here remains 2x, that x I can write x plus x. Then write down this f, then 2y you write down y plus c is equal to 0. Now here keep one of the x as it is and second x you replace by x1. Keep y as it is and second y you replace by y1. Keep g as it is, one of the x as it is, and replace second x by x1. Here keep f as it is, one of the y as it is, and transfer second y as y1. In the simple way, you can transfer this equation of general circle into equation of tangent. Means here we are transferring this x square as xx1 and y square as yy1, and this 2x as x plus x1 and 2y y plus y1. Okay, in this equation we are transferring x square as xx1 y square yy1, 2x x plus x1, 2y y plus y1, and we will get the equation of tangent to the general circle. Okay, you remember that this is equation of tangent to the standard circle and this is equation of tangent to the general circle. Okay, and it is very easy to remember the equation. Here you remember the equation of standard circle, that is x square plus y square is equal to r square. You replace x square as xx1 and y square as yy1, you will get the equation of tangent. Here you remember the equation of general circle, and if I replace x square by xx1, y square by yy1, 2x by x plus x1 and 2y as y plus y1, then we will get the equation of tangent to the general circle. Okay students, now we will see the equation of tangent in parametric form. First we know that equation of tangent to the standard circle is xx1 plus yy1 is equal to r square. We will write down that. We know that equation of tangent to the standard circle x square plus y square is equal to r square is xx1 plus yy1 is equal to r square at point P x1 y1. Now to find the parametric equation of tangent to the standard circle, we will replace or we will substitute this point x1 as r cos theta 1 and y1 is equal to r sin theta 1 in equation 1. Okay. Then we will get parametric equation of tangent. And what will be that? X into r cos theta 1 plus y into r sin theta 1 is equal to r square. Now see here, r is in each and every step. Divide throughout by r, we will get x cos theta 1 plus y sin theta 1 is equal to r. And this is nothing but your equation of tangent in parametric form. Write down. This is equation of tangent in parametric form to the standard circle. Okay. Then we will see the condition of tangency. To find the condition of tangency to the standard circle, we will first write down the equation of circle in standard form. Now see what is the equation of circle in standard form. Equation of circle in standard form is x square plus y square is equal to r square, where r is radius. But here we are taking a radius a. Therefore, instead of writing r square, I will write here a square. Okay. In the standard circle, instead of taking radius r, we are taking radius a. Therefore, equation of circle in standard form will be x square plus y square is equal to a square. Now let here y is equal to mx plus c be tangent to this circle. Let the line y is equal to mx plus c be tangent to the standard circle. Now we will rearrange the terms of this line. We will take all the terms to one of the side. Then this will be mx minus y plus c is equal to 0. I am transferring all the terms to one of the side. I suppose this is equation 1. But we know that just we have seen equation of tangent to the circle x square plus y square is equal to a square. Instead of writing here r square, I am taking a square. At point p x1 y1 is x1 plus y1 is equal to r square. But here r is a, therefore you write down here a square. Okay. Now again I will simplify this. I am taking all the terms to the left hand side. Therefore this will be x1 plus y1 minus a square is equal to 0. And suppose this is equation 2. Okay. Now if the line given by equation 1 is tangent to the standard circle, then the equation 1 and equation 2 represent the same line, that is same tangent, because we know that from any point on the circle we can draw only one tangent. Okay. If the line given by equation 1 is tangent to the circle, then equation 1 and equation 2 represent the same line, that is same tangent, because we know that by the property of circle, from any point on the circle we can draw only one tangent. Therefore this equation 1 and 2 are nothing but the equations of same line. Therefore comparing equation 1 and 2 we get. Comparing equation 1 and 2 means we will compare the terms of x, terms of y and constant. Okay. Now here coefficient of x is x1. Here coefficient of x is m. Here coefficient of y is y1. Here coefficient of y is minus 1. Here constant is minus a square and here constant is c. We are comparing from equation 1 and 2 the coefficients of x, y and constant. Okay. Now all these three terms are equal. Therefore first I will compare this x1 divided by m to this minus a square by c, and then I will compare this term y1 divided by minus 1 to a square divided by c. And comparing first this x1 to this term and this second term and third term, I will get value of x1 and y1. Then value of x1 will be minus a. Transfer this m to this side. Then this will be a square m divided by c. And what will be this y1? This y1 will be a square by c. In this way we have got value of x1 and y1. And what is this x1 and y1? This x1 and y1 is nothing but the coordinates of point P. Now this point P x1 y1 lies on the circle. Therefore it will satisfy the equation of circle. Therefore you write down. As point P x1 y1 lies on the circle, it will satisfy the equation of circle, and equation of circle becomes x1 square plus y1 square is equal to a square. Now what is the value of x1? We have got value of x1 minus a square m divided by c, and value of y1 a square divided by c. We will keep that values here, and then here I will write value of x1 minus a square m divided by c bracket square. Value of y1 a square by c, its square, is equal to a square. Now we will simplify this. This will be a raised to 4 m square divided by c square plus a raised to 4 divided by c square is equal to a square. Okay. Then after simplifying, I will get a raised to 4 m square plus a raised to 4 is equal to a square c square. Now divide throughout this equation by a square. I will get a square m square plus a square is equal to c square. Okay. Therefore this c square will be, take a square common, this will be m square plus 1. This is nothing but condition of tangency, or if you take the square root, I will get plus minus a under root m square plus 1. Okay. If I take square root, then I will get c is equal to plus minus a under root m square plus 1. And where point of contact is what? See here, point P x1 y1 is nothing but minus a square m divided by c, a square divided by c. This is condition of tangency. Either you remember this form or this form. This is condition of tangency, and point of contact P is minus a square m divided by c, a square divided by c. This is x coordinate and this is y coordinate. Okay. And you remember this as a formula to solve the problems. Then we will see the next concept, that is tangents from a point to the circle. We have already studied in our 10th standard that from any point outside the circle, two tangents can be drawn to the circle. We have studied in our 10th standard that from any point outside the circle, we can draw two tangents to the circle in the same plane. Okay, we will prove this. Here, draw the rough diagram, draw the circle, take the point P x1 y1 outside the circle. Suppose this is the point P and whose coordinates are x1 y1. Then here we will show we can draw two tangents from this point P to the circle. Take O be the center of the circle. Here you write down, let P x1 y1 be a point in the plane outside the circle. Okay. Take slope of tangent as m, and if slope of tangent is m, then what will be the equation of tangent? Therefore take this point P on the tangent and slope of tangent m, then equation of tangent in slope point form will be y minus y1 is equal to m times x minus x1. We are taking this point P on the tangent and we are supposing slope of tangent is m, then equation of tangent in slope point form will be like this. I will simplify this. Now take all the terms to the left hand side, then I will get, then transfer all the terms to the one of the side, then I will get mx minus y minus mx1 plus y1 is equal to 0. And what is this? This is the equation of line. This is the term of x, this is the term of y, and this is constant. Okay. What is the condition that the line is tangent to the circle? Distance of center from the tangent to the circle, that must be equal to radius of circle. Therefore here we will write the condition. Now we are considering this is tangent to the circle. But if this line is tangent to the circle, then what is the condition? The distance of this line from the center of circle must be equal to radius. And we will see this condition is satisfying or not. Okay. Means distance from center to the tangent must be equal to radius. And how to find the distance of point from the line? We have studied in our chapter straight line that distance of point from line ax plus by plus c is equal to 0 is, what is the formula? C divided by under root a square plus b square. and if this point is origin. Okay, distance of point, if point is origin from the line, is c divided by under root a square plus b square. C is constant term, a and b means coefficient of x and y. Okay, now distance of center to the tangent means distance of this origin to this tangent t, and equation of this tangent is what? This mx minus y minus mx1 plus y1. Okay, now what is here constant term? See, constant term is minus mx1 plus y1. This is the constant term. And what is a here? Coefficient of x means a, its square. Coefficient of y is minus 1, therefore its square. This will be in the square root. And what is the radius of circle? Here we are considering radius a. Okay, we are considering here standard circle, therefore its radius is a. Okay, now simplify this. This is nothing but y1. I will take this negative term first, then minus mx1 divided by here m square plus 1. Okay, is equal to a. Now to remove this mod sign, I will square the both sides. Now I will simplify this. I am taking this positive term first, then this negative term, m square minus 1 square 1 is equal to a. To remove this mod sign, I will square the both sides, and after squaring both sides, I will get y1 minus mx1 square is equal to a square, and this square root sign will be removed in the bracket 1 plus m square. Okay, now expand this. This will be y1 square minus 2x1 y1 m plus m square x1 square is equal to a square m square plus a square. Okay, now I will transfer all the terms to the left hand side. Then I will get here x1 square minus a square. If I transfer this term to the left hand side, then these terms becomes negative. Take m square common from these two terms, then this will be x1 square minus a square times m square. Then write down this term minus 2x1 y1 m plus y1 square, and transfer this to the left hand side. This will be a square. Okay, now what is this? This is x1 square minus a square m square. This is plus in the bracket minus 2x1 y1 m plus take this constant to one of the bracket, and this is the quadratic equation in m. This is the coefficient of m square, this is coefficient of m, and this is the constant term. Okay, now as this is quadratic equation in m, it must have two roots, say m1 and m2. Therefore this has two roots, say m1 and m2. And here we are supposing m as slope of tangent. Therefore this m1 and m2 are nothing but slopes of two tangents. Therefore write down, as we are supposing m slope of tangent, therefore m1 and m2 are slopes of two tangents. Therefore, in general, we can say two tangents can be drawn to a circle from a point outside the circle in the same plane. Therefore, you write down, thus two tangents can be drawn to a circle from a given point in the same plane. Okay, see the diagram? In this way, we have proved that from a point outside the circle, we can draw two tangents to the circle. Okay, now we know that if ax square plus bx plus c is equal to 0 is a quadratic equation, then what is sum of roots? We know that sum of roots is minus b divided by a, and product of roots is c divided by a. We know these two formulae. We have studied this formulae in your 10th standard in the chapter quadratic equation. If ax square plus bx plus c is equal to 0, then sum of roots means minus b divided by a, and product of roots means c divided by a, where a is coefficient of x square, b is coefficient of x, and c is constant. Okay, now here we will find the sum of roots and product of roots. Okay, now what will be sum of roots here? Here roots are nothing but m1 and m2. Therefore write down here sum of roots, that is m1 plus m2. Okay, and what is here a? See here, a is coefficient of m square, that is x1 square minus a square. B is coefficient of m, that is minus 2x1 by 1, and here c is this constant term. Therefore, write down sum of slopes minus time. B means this middle term, minus 2 x1 y1 divided by a means coefficient of m square, that is x1 square minus a square. Now we will simplify this, minus minus become plus 2 x1 y1 divided by x1 square minus a square. Now we will find the product of roots. Product of roots is c divided by a. C means constant. This y1 square minus a square divided by a means coefficient of m square, that is x1 square minus a square. Okay, in this way we can find sum of roots and product of roots of this quadratic equation, where m1 and m2 are slopes of two tangents. Okay students, now we will see the last concept. What is mean by director circle? What is mean by director circle? The locus of point of intersection of two perpendicular tangents to a circle is called director circle. We will first write down the definition here. Now see the definition of director circle. The locus of point of intersection of two perpendicular tangents to a circle is called director circle. To get clear with this concept, let's try to draw the diagram. See here. Consider this innermost circle. Suppose its center is at origin, and we will draw two tangents, two perpendicular tangents to this circle. Suppose this is T1 tangent and this is tangent T1 dash, and these are perpendicular to each other. I am drawing here two tangents T1 and T1 dash, which are perpendicular to each other. Okay. Now I will draw the second pair of tangents. See here. Now I will draw here second pair of tangent T2 and T2 dash, such that both are perpendicular to each other. Then I will draw the third pair here. Now see here, with the diagram definition will be more clear to you. The locus of point of intersection of two perpendicular tangents. Locus of point of intersection of two perpendicular tangents. See here, these two tangents are perpendicular to each other. These two tangents are perpendicular to each other, and these two tangents are perpendicular to each other. And see, their point of intersection is what? If we draw a circle from the point of intersection of all these tangents, then we will get the another circle. And this outermost circle is called director circle of this inner circle. In this way, if we draw the perpendicular tangents to this innermost circle, and if we draw a circle from the point of intersection of all these circles, then we will get the another circle, and that circle is called director circle of the innermost circle. Okay. Now we will find the equation of director circle. For that, if we draw mutually perpendicular tangents, then we know that as these tangents are perpendicular to each other, product of their slopes will be minus 1. Therefore, we will write down this. Okay. Suppose this is point P here, and from this point P we will draw two tangents to the circle which are mutually perpendicular to each other. If slope of one of the tangent is m1 and slope of other tangent is m2, and as tangents are perpendicular to each other, therefore product of their slopes is equal to minus 1. Okay. Now just we have seen in our previous concept that if two tangents are perpendicular to each other, then their product of slope is y1 square minus a square, x1 square minus a square. Just we have seen in the previous concept. Now we will simplify this. Comparing these two equations, we will get y1 square minus a square divided by x1 square minus a square is equal to minus 1. Now we will simplify this. Then this will be minus time x1 square minus a square. This is minus x1 square plus a square. Okay. Now transfer this negative term to this side. I will get x1 square plus y1 square, and transfer this a square to this side. Then a square plus a square will be 2a square. Okay. And what is this? This is nothing but equation of directed circle. In this way, we have got equation of directed circle. And here radius of this directed circle is root 2 times a. Write down the equation of directed circle. X1 square plus y1 square is equal to 2a square. Okay. Now what is this? This is nothing but root 2 times a square. What will be the radius here? Radius is root 2 times a. Means if radius of circle is a, then radius of directed circle will be root 2 times a. Okay. And obviously directed circle is a concentric circle where radius is root 2 times the radius of circle. We will write this. In this way, if the radius of given circle is a, the radius of directed circle is root 2 times a. Obviously, directed circle is a concentric circle whose radius is root 2 times the radius of given circle. See the diagram. If the radius of this circle, innermost circle is a, then radius of directed circle means the circle outside circle will be root 2 times a. And obviously this directed circle is concentric circle with the given circle, means they have the same center, only they differ in radius. Okay students, in this way in today's lecture we have seen parametric form of circle, then what is meant by tangent, equation of tangent to the standard circle, then equation of tangent in parametric form, condition of tangency, then tangents from a point to the circle. Also we have seen the directed circle. Okay students, we will meet in the next lecture, and in next lecture we will take the exercise 6.3. Okay students, see you in the next lecture. Till then, goodbye.